Okay, so we're going to take a look at a problem here. It's kind of got a lot going on, which is good. And there's some points where I'm going to have you guys pause this so you guys can attempt this, see how you do. So we've got this torch, an oxyacetylene torch, and they tell us the temperature's around 2,000 degrees. They say we have 175 grams of the acetylene and oxygen. It undergoes combustion. 68.5 liters of carbon dioxide are created. It has a density, and they want to know percent yield. Okay, so let's kind of digest all of this. So first of all, if they tell you that it's a percent yield problem, they have to tell you what happened in real life, because you don't have an oxyacetylene torch. You're not actually doing an experiment. So they have to tell you how much was created. And so they have done that right here. The 68.5 liters of carbon dioxide, that is what we would call an actual yield. So this is what happened in real life. You don't have the torch. You're not out there welding, making skyscrapers, whatever. So they have to tell you. So there we go. That's what we're going to compare to. So that's 68.5 liters. When we do a percent yield problem, it's going to be that number on top. And then we've got to figure out what goes down here. Like what are we dividing by? So we've got to figure out what's called the theoretical yield. All right. So we're looking for the theoretical yields. That's what's going to go right in that spot. So first thing is we need a formula. And you have everything you need to find it. You've got the hydrocarbon, the oxygen, and you know it's combustion. So pause the video and try to come up with a balanced equation. All right, let's see if we can get it figured out. So we have some acetylene. We have some oxygen. We've got some carbon dioxide. And we have some water. Okay, so we have all the pieces that we need to balance it up. So 2 carbons, if you put a 2 here, you have 4 plus 1, 5 oxygens. And so it looks like the hydrogens are okay. Looks like the carbons are fine. But the oxygens, see, we've got 2 times 2 is 4 plus 1 is 5. So that's going to be a bit of a problem because it's kind of hard to get 2 to multiply something to get 5. So what I would normally do is just go ahead and plug in the 2.5, right? Because that's going to get you to 5. You just aren't allowed to have a decimal. So let's go ahead and double everything. So let's make that a 2. 2.5 doubled is 5. 2 doubled is 4. And then 1 doubled is 2. So there we go. There's your balanced equation. And so now we have to set up the problem because we've got to figure this out, right? So we're trying to figure out the theoretical yield, trying to figure out what goes down there, right? So that's what we're trying to do, trying to figure out this right here. Okay, so let's go ahead and write down the pieces real quick. And we've got 175 grams of the acetylene and the oxygen. So they have the same exact amount of each one. So let's just go ahead and write that down on top. I think this is very important to do. And then they said that we created 68.5 liters of this CO2. So what we're going to do is we are going to find CO2 because we know that this is what was created in real life, but we need to figure out how much was supposed to be created. So we've got to do the math and we're going to figure this out. So our question mark is going to be the CO2 in liters. Now the water, We're not going to use anything without water, so we put X on top. Now, it's a limiting problem, right? Because we've got two chemicals here, and we're looking for a third. Well, you're going to need to do a limiting problem and then circle the smallest one. So pause the video, give it a whirl, see if you can do the stoic and figure out how much CO2 we were supposed to get. All right, let's see how you did. You might have had a few problems, and that's perfectly fine. We'll figure it out as we go. So I'll do the first one here. So 175 grams, and then I would take my, need my unit, my C2H2, and then I would convert that into moles. And then I would add this up on my periodic table, right? So 12.01 times 2 plus my 1.01 times 2, 26.04 is what that's going to weigh. So that's going to go here. And then we're going to do our mole ratio. So we're going to turn it into our question mark. So that's going to be 4 moles of CO2 on top. And then it looks like we've got 2 moles of the acetylene on bottom, like that, okay? And then we're supposed to get it into liters. So we're trying to figure out how to do this. Now, here's the problem. This problem is at 2,000 degrees, which means I cannot use 22.4 because that's not standard temperature. So I'm going to have to find a different way to get to liters. Well, luckily they gave us this density, and that density is saying, okay, 1.85 grams per liter. That's how you're going to get into liters. So if you have moles, what you want to do is you want to go to grams, and once you get to grams, you can get back into liters. So CO2, we're going to add that up. So that's going to be 12.01 for the carbon plus the 2 oxygens, so 16 and 16, and you get your 44.01. So that's going to go here. And so let me show you the units canceling. Very important you cancel units. If you're not doing that, you are making big mistakes, because when I have you do the work, I'm going to be looking for this. So moles top bottom, C2H2 top bottom, moles top bottom. Okay, right now we've got grams of CO2. So if we come back over here to density, it's 1.85 grams for every 1 liter. Well, we want liters to go here. So what we'll do is we'll use density as this final conversion factor, and it's going to be a little tight on space. So I'm going to maybe clean this up a little bit, and I'll rewrite this in a bit, but I need this space right now. So I'm going to clean that up real quick. And let's put my last step in there, and let's change the color to green so we can understand that it's a different conversion factor. And so we're going to use, on the bottom, 1.85 grams. Reason it's on the bottom, see, I want the grams to cancel. So it's 1.85 grams for every 1 liter. Okay, so if you look, grams top and bottom, we're left with CO2 and liters, which is exactly what we want, okay? Because we want to compare to this number right here. Okay, so let's go ahead and run it through a calculator. 175 divided by 26.04 times 4 divided by 2 times 44.01, and then divided by 1.85. So that's going to give me an option. And then we are going to look at the second option. All right. So this one was, I'm going to double check my math real quick. 175 divided by 26.04. Remember, I'm doing these as well as you, so I think I made a mistype there. Okay, so 3 sig figs, I'm going to go with 320 liters. So let's go ahead and put option 1 right here, 320 liters. Okay, so let's do option 2. Go ahead and keep the green pen. So option 2 is going to be very similar. 175 grams of oxygen, and then 1 mole. And oxygen, 2 of those guys, 16 and 16. Should have that one memorized by now. And now we're going to still turn it into the CO2. And then the 5 goes on the bottom, right? Because of the 5 moles of O2. And then this is going to be identical, 44.01 grams for every 1 mole. And then our last step is going to be the same, 1 liter on top, 1.85 grams. So we're using the same density because it's the same chemical. So it's still the same thing. So these are identical for both because it's the same stuff. All right, we're just trying to figure out which one's smaller. So let's run it through. Oh, let's check our units real quick. Didn't do that. Grams, good. O2, gone. Moles, gone. Moles, gone. We're keeping the CO2. Grams cancel. Okay, top and bottom worked out. Okay, 175 divided by 32, enter, times 4, enter, divided by 5, enter, times 44.01, enter, divided by 1.85, enter. Okay, so after all of that, I'm going to get an answer of, for this one, 104 liters. Okay, I'm going to pause it here. I'll finish this question up on the next video. Minutes, I think I can finish it on this video. I thought I was running out of time. So we can finish this one up. We're going to keep the 104 because it's smaller, limiting. So limiting problems, you pick the smaller one. I'm going to cross out the 320. That never happened. I'm now going to do my percent yield, and that's going to equal my actual, so my 68.5 liters. That's going to be my actual. That's my actual. That's what was created in the real world. And then we're going to go ahead and divide that by the 104 because that's what was supposed to happen. We did the math, we did the pencil and paper, and we found out that, okay, theoretically, that's what was supposed to happen. All right, so we're going to do that. And then we're going to multiply this by 100. And it's going to give us how good a job we did. So let's go ahead and try it. 68.5 divided by 104, enter, times 100. And if you go to 3 sig figs, it looks like it's going to be 65.9%. 65.9%. And that is a percent yield. So